The reason that most people get this particular question wrong is that they just don't know where the error is going to come from. So if we look at this, we can see there's clearly a line. So we might want to write, get back to basics, right? Write y equals mx plus b and make sure you know what they're asking about. So y equals mx plus b. We read the story, line of best fit, according to line of best fit, which defines close to the predicted increase in total fat in grams for every increase of 1 gram in total protein. So increase is code for slope. And we might want to check that the slope is being phrased in a logical way, right? We know that slope is going to be the change in y over the change in x. So in this case, they're saying the increase in fat, which is in fact y, for every 1 gram of protein, which is x. So that makes sense. It's not defying our expectations, flipping that upside down at all. It makes sense. So the mistake most people make is, we know when we're trying to find slope, we need to find some points and calculate the change. But there's no spot on this line of best fit where the line kind of neatly hits a corner of the boxes. And that's usually what we're looking for. So we're going to have to estimate. But because of the fact that we're estimating, there's always a chance for error, right? Like we could say that something looks like 36, but it's really 38. And so to account for that problem, we want to spread out our estimates as much as possible. So the mistake people make is they pick a point like this down here at, whatever that is, 8 on the protein side. And then they pick another point that's really close, like right here, and they just kind of try to measure the slope in between those two things. The better, safer move is to spread out the points. So pick the point down at the end, but then pick the point all the way up here. And when I say point, I don't mean the dots, right? The dots are not helpful here. It doesn't matter whether they're close to the line or not. The dots are the actual values, but we're being asked about the line of best fit. So what I'm doing is I'm looking at the line itself and trying to estimate where it starts and ends. And by spreading out the points that I use, if I do estimate wrong, that error is going to be kind of like averaged out. And so it won't hurt me as much. I might not get one of these answers exactly, but I will still get kind of close that it will only be one or the other. So let me show you what I mean. Let's take these points and let's write some coordinates down here. So this is probably something like 9, 16. Right? It's between 10 and 20, looks about halfway, but maybe a little bit more. So 9, 16. And this point looks like, 48 on the x. And then it's about halfway between 70 and 80, so let's just say 75. Okay, so change in y over change in x means I'm doing 75 minus 16 over the x change, 48 minus 9. So what is that? Use the calculator. We've got it here. 75 minus 16 is 59. And 48 minus 9 is 39. And then 59 divided by 39 is 1.51. So I'm pretty darn close. And so that's okay, that's fine. That's not exactly, perfect, but that's because we're estimating. I think a lot of people are very nervous about estimating on the SAT, but they're making us do it here. There's no other way to get this. So just spread your points out, and what happens is if you're off by a little, it won't matter as much because you'll kind of be averaging out that mistake, that estimation mistake. It's fine. If you're close together, don't be surprised if you get something like 1.74 or 1.76, something that looks like it could be either choice B or C. And, that's because your error that's supposed to happen is a little bit less spread out, and so it's causing more of an issue for you. That's usually why people get this wrong. So hopefully that helps, and if that's the reason, sorry, but now you just kind of learned a good lesson for the next time.